So graph theory is a topic in mathematics that we're just barely touching the tip of the iceberg on it. There are mathematicians who devote their career to studying graph theory and finding applications for this. Graph theory started with a mathematician named Leonhard Euler. His last name is spelled E-U-L-E-R, but it is pronounced like O-I-L-E-R. And the very first problem, all of mathematics, all the branches are going to start with some problem that was presented to a mathematician. And this problem was presented to Leonhard Euler. Similar to this, not quite this layout, but there was a town, Königsberg, Germany, in the 1700s, because that's when he lived, Leonhard Euler. And the people of the town would take a stroll for recreation. They would cross some bridges to some islands. And they kind of wondered, when I take this walk, can I cross every bridge just one time and end up back at my house? So take their walk on one day. Try it, didn't happen. So the next time they take a walk, they'll try a different route. Just because they couldn't find a route the first time they looked, probably wasn't the first time they walked, but they, started talking about this question. Just because they didn't get one on that route didn't mean there wasn't a different route that would work. So next time they take a different route. Didn't happen, they take another route. So they're wondering about this, and they gave this question to Leonhard Euler. And that was the very first graph theory problem. He determined it could not be done, but gave a sound reason why it could not be done. So this problem does not model the bridges of Königsberg, but it does model bridges with islands. So it's quite a historical type problem. Let's read it. Use vertices to represent the land masses and edges to represent bridges. Which graph models the layout of the city shown in the map? And what I would do is put a dot on each landmass. One dot, I see like on the south side, I got 3 bridges coming to the south side, but one dot will do. One dot at A, one dot at B, one dot at C. I like to think about it as there's a race. 5K, 10K. When you cross a bridge, you have to go to this check-in table on that landmass. The check-in table is where the dot is. I said a race, but you could take whatever route you want. You just have to cross every bridge. So I'm going to draw an edge from the dot on island A to the dot on the north side. I'll draw a line from the dot on B to the north side, crossing the bridges. There is a bridge that goes from C to the north side, so I'll draw a line that way. It doesn't matter if it curves. There's a bridge that goes to the south side from A. There's a bridge that goes to the south side from B. There's a bridge that goes to the south side from C. There is a bridge that goes from B to C and one from A to B. There's my graph. What I will do is lift that graph, do what I call a cleaned up version. I'm going to write it on the side. I had A, B, C, south side, north side. Now, I'm writing the vertices to kind of match the geography. They don't have to be written like that. Sometimes the answer is going to be this one where they're all in a straight line. But let me, on my cleaned up version, you can draw these straight. You can draw them curved, it doesn't matter. A to N, B to N, C to N. There's a bridge from A to B. There's a bridge from B to C. There's a bridge from B to S, S to C, A to S. Well, it looks like it's the second one. It just happens to be that that second one is drawn the same orientation. But sometimes the correct answer is going to be the one that are all in a straight line. Oh, look at the one that's in a straight line. They have a line from N to S. Again, you got that merging of the lines, which should not be happening. This one shows a bridge from the north side to the south side. That's not shown in this picture.